And taking a look at the national forecast, there's a 30% chance of boredom, a 60% chance of excitement, and 100% chance of...
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by Co-Winky Dink, Inc., the probability people.
The world is full of possibilities. And if you think about it, everything that happens really has a chance of happening or not happening. Everything has what we call a probability. So today, we have 3 doors, and only one of them leads to the lab. So each door has a 1 in 3 probability of taking us where we want to go. The lab is behind door number 1, door number 2, or door number 3. Let's start over here with door number 1. Should have had this on. Well, now there's 2 doors left. There's a 1 in 2 probability. This one is probably it. Right to the red dust. I did not see that coming. Well, there's just 1 door left. Door number 3. So, let's get on with the show.
Bill, behind you. Bill.
Huh? Good thing I have my mask on. See, there's ways to figure out the chances of something happening or not happening. It's what we call in science probability. Take a look at this. It's our giant coin-flipping machine of science, the Flipmaster 50/50. Here are the giant coins. This side's heads, and this side's tails. Watch. 3, 3, 3, 2, 2, 1. See, it landed heads. If you think about it, it's going to land either heads or tails every time. Now, heads or tails means a 1 in 2 probability for either one. See, we can't predict exactly which way it's going to land on every toss, but we can predict exactly for a whole bunch of tosses. Eventually, there'll be exactly as many heads as tails.
Heads.
Tails. Try again.
Heads.
Tails.
Heads.
Tails.
Come on, that coin's rigged. It's only landing on tails.
Looks okay to me.
It's gotta be tails.
Heads. If you look at it this way, it's pretty simple. Sometimes there's a long run of heads or a long run of tails. But if you flip the coin enough times, the probability always averages out to be 1 chance in 2.
50-50.
Oh.
Gumballs. I'm going for a red one. I got a blue one. See, that's probability in action. See, in this gumball machine, there's 6 different colors of gumballs. Let's say there are 100 altogether.
There are 100 altogether.
Here they are. So, see, there's 40 blue ones, 20 green ones, 10 red ones, 10 pink ones, 10 orange ones, and 10 yellow ones. So since there are more blue ones than any other color, we'll probably get a blue one. Let's try it. Yeah, see? We got a blue one. Let's see if we can get a blue one, followed by, a red one. We got a green. We didn't get another green. Oh, here's yellow. Orange. See, the more combinations you add, the harder it is to get it to come out.
Oh, great wizard, what are my chances of getting home safely?
Chances? You dare ask me what your chances are?
Well, you are the Wizard of Oz, aren't you?
I am the great and powerful Wizard of Oz. I know all probabilities and everything and everyone. There's a 72% chance of rain tomorrow. And if you want to improve the chances of getting home safely, wear a seatbelt. Now, you're wasting my time. Go on, get up. Pay no attention to that man behind the curtain. He's a nobody. I am the great and powerful Wizard of Oz.
Why, you're no wizard!
I am the great and powerful.
What's the use? You're right. I am no wizard. I mean, it doesn't take a wizard to know about common sense and probabilities, which helps us predict events.
I know, but can you help me get home?
Oh, well, let's see. Well, there's a number 55 bus leaving in about 10 minutes. Odds are you could catch that one.
By figuring out what's average, we can predict the future. Please consider the following. This machine allows these balls like this, to fall from way up here to way down there. Now, the balls don't fall straight down. Now, every time a ball hits one of these bars, they bounce and jostle at random, this way or that way. It always never goes straight down. Now, we can't predict the path of any one ball, but we can figure out where most of them are going to land. Now, since most of the balls get bounced as many times to the left as they do to the right, most of the balls end up in the middle. That's the average. Every time we do this, the balls end up stacked in just about exactly the same shape. Scientists like to call this a bell-shaped curve, or just a bell curve, because it's shaped like a bell. How wide or pointed the bell-shaped curve is depends on how near the average things are. The closer things are to the average, well, the narrower and more pointed the curve. The farther from the average, well, the more flattened and spread out it is. The probability that makes this shape is part of the nature of the world, because so many things in the world depend on probability, and slight differences are normal. We see a lot of bell-shaped curves in nature. They're normal. You think I'm normal? Thank you for joining me on Consider the Following.
I'm a girl. Could have just as easily been a boy, though, because the probability of becoming a girl is always 1 in 2. See, inside each of our cells are these things called chromosomes, and they control whether we become a boy or a girl. Your mom has 2 X chromosomes in all of her cells, and your dad has 1 X and 1 Y chromosome in each of his cells. Before you're born, your mom gives you one of her chromosomes and your dad gives you one of his. Mom always gives you an X. And if dad gives you an X too, then you become a girl. But if he gives you his Y, then you become a boy. See, there are only 2 possibilities. XX, a girl, or XY, a boy. The chance of becoming either a boy or a girl is always 1 in 2. A 50-50 chance either way. It's like flipping a coin. X, you're a girl, Y, you're a boy. Some people are just lucky, I guess.
When you buy a car, you have to get insurance. Now, how much insurance costs is based on probabilities. See, there's so many cars driving all over the place, and once in a while something goes wrong. Like, cars hit each other. And sometimes cars get broken into, the radio gets stolen. Believe me, it happens. Anyway, insurance companies keep track of these problems.
Bill, there's some...
how often they occur and where they occur.
There's some guys
By
jacking your
computing
car.
the probabilities of things going wrong, insurance companies can charge you the right amount for insurance. Now, believe me, stuff like this hardly ever happens. I mean, if it did, it'd be impossible to insure anybody.
Stripping your car,
It's
Bill.
a small percentage of cars that run
Bill.
into problems. Well, it's a beautiful day for a drive, isn't it? What? Most states have a lottery. It's a game people play for money. Now, most places, your chances of winning are 1 in 5 million. And let me tell you, that is one small probability. Take a look at this. It's a box with 5 million packing peanuts in it. Now, in there somewhere, there's one red one, like this. Trying to find it's like looking for a needle in a haystack. It's like trying to find a red peanut in a big box. See, it's 1 in 5 million. It's like the lottery. So suppose you're trying to get the red peanut out of here, and every time you took a peanut out, it cost you $1. So to take a handful, that would be about $10. Now, do you see? You'd probably never find the peanut, and you'd go broke. That's because a 1 in 5 million chance is a very low probability. Wait, I think I see it.
Bill.
Wait.
Bill.
It's right there.
Don't try it, Bill.
Hang
Bill.
on. Wait.
Bill, no, Bill. Oh, no.
It's down here. I know it's down here. I know it's here.
Hello, I'm Lance Yardstick.
And I'm Timmy Ticker, and we're here today for the really big game between the Calgary Card Counters and the Oakland Odds.
Do you think the counters can beat the odds, Timmy?
Well, it can go either way, Lance, and right now I'd say it's 50-50.
The captains are shaking hands, preparing for the opening coin toss. I believe it's a replica of a silver dollar.
And it's another day at the ballpark with one side heads and the other side tails.
Right you are, Timmy. Here we go. The odds choose tails. It's up, and it's heads.
That is unbelievable.
What are the chances of that?
I'd say they're about 1 in 2, Lance.
What a paragon of probability.
I couldn't have said it better myself. We'll be back after this.
Play the lottery. Chances are 1 in 5 million, or maybe even less.
We're back. After 83 tosses, things are finally evening up with the score tails 42, heads 41.
And that's hard to believe, especially since tails just stormed out of the gate with that early, seemingly insurmountable lead of 19-8.
Yeah, but since coin flipping is a 50-50 game of chance, Timmy, it was no surprise when heads rallied.
She knows the odds, she takes her chances, she slid through heat and avalanches. Probability girl, she will rock your world.
We can make predictions based on stuff that's happened in the past. What are the odds your parents are going to think you're all pretty? Oh.
What are the odds that in a room full of people, you'd find 2 with the same birthday? If you have a classroom with just 23 people in it, the probability that 2 of them will have the same birthday is about 1 in 2, 50-50 odds.
And you're saying to yourself, how can that be possible? I mean, there's 23 people and a 50-50 chance. Well, you see, the chances of someone not having your birthday are 1 minus 1 over 365. So the chance of your birthday is 1 minus that. And that comes out to be 0.0027 or 0.27%. You know, that's not particularly good odds. That's with just 2 people.
And if there are 3 people, the chances that 2 have the same birthday are 1 minus 1 minus 1 over 365 times 1 minus 2 over 365. Chances are slightly better, about 0.82%.
Yeah, and if you keep going, if you keep doing the math, for 23 people, you get the same thing, so you just keep carrying the math out here. So it's 1 minus 1 over 365, 1 over 2 over 365. For 23 people, so it's 1 minus 23. Are you with me? So you get 1 minus 23 over 365. You do the math. How does it? 1 and 2.
Hey, if you don't believe us, try it yourself. Make a chart and list the birthdays of everyone in your class at school. In a class of 23, the chances are about 1 in 2. 50-50 that 2 of you have the same one.
My name's Louise Vicencio, and I'm a wildlife biologist interested in studying shorebirds. This project will allow us to learn a lot about the migration ecology, how long the birds stay at different migration spots, how long it takes them to travel from one spot to the other, or how fast they are flying. Probability is very important because it allows us to gain an immense amount of information about a whole population just by sampling a small number. We're going to let this bird go and head on its journey north, 3,000 kilometers up to the breeding grounds in Alaska. The transmitters work by emitting a signal that we're able to pick up with a receiver, and we monitor the birds on the ground and from airplanes at different locations where the birds stop to feed. The probability of finding a banded bird is pretty slim. It's probably less than 5% that we would ever recover this bird. But the probability of finding a bird with a radio transmitter is much greater, about 80%.
Do you have a lucky number? Is it 7? Yeah, so is mine. Actually, I don't have a lucky number. But in some situations, 7 is a very likely number. Like when you're rolling 2 dice. See, with 2 dice, there's no way to get a 1. But if you roll 2 ones, you get a 2. Then a 1 and a 2, or a 2 and a 1, make a 3. So there's 2 ways to get a 3. That makes 3 ways to get a 4, 4 ways to get a 5, 5 ways to get a 6, and 6 ways to get a 7. See, no matter what the first die comes up, there's a way for the other die to make a 7. Well, that leaves 5 ways to get an 8, 4 ways to get a 9, 3 ways to get a 10, 2 ways to get an 11, and just 1 way to get a 12. But still, the most likely number is a 7. You have a 6 out of 36 chance. That's a 1 in 6 chance of getting a 7. Let's try it. This is our giant dice-slinging catapult of science.
Whoa.
Come on, 7. Are you okay?
I'm okay. I'm okay.
You okay?
Yeah. Did you lose a lens?
Oh, hi. I was just looking at the clover here. I'm trying to find a 4-leaf one. See, most clovers have 3 leaves, but we're looking for one with 4.
Oh, how do you know?
You might say it's luck, but it's not really luck, it's probability. Here, take a look. So here's a patch that I roped off earlier. It's about 10 square meters. I went through it as carefully as I could, and I found one 4-leaf clover. Here it is. See that? Anyway, I figure there's about 5,000 clovers in this patch. So that means there's a 1 in 5,000 probability of finding a 4-leafed one. This is how scientists make predictions about the future. So if we go to another part of this park, the probability of finding another 4-leaf clover is around 1 in 5,000. But suppose we were looking for something else. Suppose we were looking for a a 5-leaf clover. I'll tell you the truth, I've never seen a 5-leaf clover, never even heard of a 5-leaf clover, so the probability of finding one is small. Teeny, tiny probability. You'd be like standing in the middle of this park and getting hit by a giant wrecking ball. I mean, it could happen, but it's a very, very unlikely
You don't
thing.
think, oh my gosh,
Hey,
this could.
hey, wait a minute. Hey, I think I got one. Wait, hold it. No. Oh, I see what the leaves are just folded over is all that.
I'm flipping the coin and I'm keeping a tally. Heads is ahead, but then tails starts to rally. I keep on going, I'm getting 50%. You have to admit this is money well spent. Some events are so rare that you just can't expect them. A long shot probably won't be selected, but once in a while a long shot hits, or else you'd have to say that the chances are zip. Probability, or the chances it will be. Flipping coins and rolling dice, we'll have to wait and see. Probability depends on the circumstances. If I figure them out, then I'll know the chances of something happening. Which will it be? If I had to guess, I'd say it's 1 in 3. Probability, or the chances it will be. Flipping coins and rolling dice, we'll have to wait and see.
There've got to be 2 of them that are alike. I mean, they got 6 sides. I mean, it's gotta be here. Oh, hi. Well, that's our show. Thanks for watching. If you'll excuse me, I've got some hexagonal tine interstices to collate. They're stochastic, you know. See ya!
Produced in association with the National Science Foundation.
See, so you almost never hear of a 0% chance of rain or a 100% chance of rain because weather is so unpredictable. You didn't see that coming, did you? That we would have the sprinkler with the rain. You didn't predict that, did you? You didn't think that was probable. That we'd go for that old ice-cold water down the back of the neck gag. Did you? But we did. Woo! Get patterns of tiny ice crystals. So to form a 6-sided flake, there's so many different crystals that the probability of finding 2 flakes identical is very, very small. There's so many hugely gigantically big numbers of tiny crystals hooked together that the probability is start over. Good probability for you.